designing more fitting environments. Just a reminder, PSYs are examinations of the effectiveness of the design environment for human occupancy, and they can vary in size and scope, breadth of focus, timing, and usability. And we know that despite the benefits, the knowledge gained has not been disseminated and used enough. Depending on the goal, POL could include multiple methods. It could be based on interviews or structured questionnaires. For example, if you want to measure what is the level of usability of the space and the design, or satisfaction. It can include observations, walk-through visits for technical inspections, for example, or behavioral observations, mapping physical traces and so forth to make sure that the space is adequate for the needs of the user. Or can use archival data if the main goal is to improve effectiveness in terms of use of resources. Can be the electricity bills, comparing before and after. It can be an analysis of the construction materials used and how green they are and so forth. Or can be, I can use all of them. Let's look at this case study. Researchers were interested in measuring employee satisfaction, productivity, and well-being after the design of a new office space. What the results show is that the employees were more satisfied with the new work environment, but not in every aspect. If you see the spider web graphs, what they show is that in most areas there were improvements, but on the left you can see that the red is narrower in terms of personal control of the immediate environment. That means there was a reduction in the satisfaction regarding personal control. And if you look at figure 4, there was also not improvement in terms of satisfaction with the visual privacy. In terms of efficiency, energy efficiency, the new building was significantly more efficient than the old one. If you look at the graph bar, it shows the consumption patterns for a year of electricity, gas for 3-month periods at a time. The red bars are the readings for the new office. And it shows clearly how almost everything went down except gas in July, September. An efficient and effective POI should enhance the understanding and prediction of the design and construction of built environments. It should be simple, easy to use, easy to obtain at a reasonable cost. It should be precisely defined. So when 2 or more observers are conducting the assessment, they can arrive at the same value. And on top of that, it should be valid in the sense that we are measuring the property we state we are measuring. And it should be robust, meaning every time we perform that observation using that scale, we arrive at the same value. Many healthcare facilities have embraced POIs and are in the early stages of developing guidelines for evidence-based design to achieve the best possible outcomes in hospital settings. These are encouraging steps, although there is not yet an accepted standard for all healthcare settings. As we have seen in the class, there are multiple challenges, so we need to really pay attention to alternatives and test new ways of solving the problems of urbanization and human built environment. And there are new, really interesting ideas for the desert, for example, that take advantage of nature ways to solve these issues. And there is also new methods of construction, as the next clip shows.
It costs about $237,000 on average to build a home in the United States, and the work typically takes 3 to 6 months. But crews in Austin, Texas are bringing 3D printing technology to home construction. They say they figured out a way to build a house in less than 2 days for a fraction of the cost. Oh my, Omar Villafranca looks at this new approach.
This isn't a technology that's going to help a little niche of the way we think about children. This is a paradigm shift in the way we build houses.
This technology starts with a 1-ton 3D printer, which squeezed out enough concrete to build a small 2-bedroom, 1-bathroom, single-family home.
It's a house printing robot.
Jason Ballard is co-founder of Icon, one of the companies behind the project.
This house right here was printed in 47 hours at quarter speed. At full speed, could have printed this house in 11 or 12 hours.
A home in 11 or 12 hours.
And that's on version 1 of the technology.
And it's designed to take families that have been living in tents or shacks and to bring them into what we believe is a beautiful home that they can build their lives on for the next few decades.
Brett Hagler runs the nonprofit News Story. He's hoping to bring this technology to poor communities in El Salvador by the end of next year.
When you see a home like that, do you get excited about the future?
I do. I'm excited about everything concrete. All right, so you're going to add your cement?
University of Texas engineering professor Reza Douglas Farran is an advisor on the project. While she sees the potential for 3D printed homes, she questions how the concrete mix will stand up over time.
Is there enough data out there saying that these kind of homes can be safe?
No, there's not.
Does the building of these homes need to wait until there's data, or do the homes need to be built and then study the data?
You have to do them both at the same time. If we wait until there's data in order to build it, you're never going to build it.
Icon will use this model home as an office for the next few years, while third-party labs test its long-term durability.
We're going to make ourselves the guinea pigs before we put another family's life in the mix.
And this particular design has limitations. Utilities like electric and plumbing still need to be installed outside the walls.
Right now it's just going to be a novelty. It's just going to be eye candy.
Even if all goes as planned, it will likely be years before 3D printing becomes a mainstay of U.S. residential construction. For CBS This Morning, Omar Villafranca, Austin, Texas.
As Evelyn Linder states, there is no time for pessimism. There are way too many challenges that need to be addressed. We need to alleviate poverty and provide access to water, sanitation, power, and essential services to large portions of the population. We need to provide shelter for those homeless and those displaced by weather events. We need to create better spaces to improve dialogue that is in such a bad condition and mitigate the effects of rapid urbanization. We need to meet the needs for those disabled and other at-risk and vulnerable populations and reduce the footprint of the built environment. So let's move and look for opportunities.